Hi everyone, my name is Sandeep. Welcome back to another session of BGP. Let's start for today's session. Okay, so today we are gonna teach BGP Split Horizon Rule and how to overcome this. So there are two solutions: route Reflector Client and BGP Full Mesh. So before we start, let's understand our topology. Let me take a screenshot of this diagram. Okay. So what BGP Split Horizon Rule says that if you have an IBGP neighbor between two routers, the route learned from one IBGP neighbor will not be sent to the next IBGP neighbor. Let me explain it more. Let's say I have this 200.0.0.0 network which is learned on router 1, okay, and this route is being sent from router 1 to router 2. So this route has come here onto router 2, 200.0.0.1. This route will not be sent to the next IBGP neighbor. So this route 200.0.0.0 will not be sent to router 3. Okay, this is a BGP split horizon rule. This is used to avoid the routing loops, and by default BGP is gonna uh, block this route from advertising from router 2 to router 3. Okay, so we are going to do the practicals and we are going to see how it is gonna work. So to give you a brief, we have three routers: router 1, router 2, and router 3. Uh, all these three routers are in BGP Autonomous System 100, and we are going to advertise this route 200.0.0.1. Okay, so let's go ahead and start doing the configurations. We will understand how the routes are not getting propagated from router 2 to router 3. We'll verify the BGP routing table on router 3, and then we will go towards the solutions, that is route reflector and full mesh. Okay, let's jump ahead onto router 1. Okay, this is my router 1. I'm going to quickly configure the IP addresses. Let's say conf t interface f80/0 IP address 10.1.12.1 255.255, and I'm going to execute no shut on this. That's it. So let's jump on router 2. Conf term interface f80/0 IP address 10.1.12.2 255.255.255.0. No shut. Interface f80/1 IP address 10.1.23.2 Let me no shut this. Let's verify the connectivity between router 2 and router 1 first. Ping 10.1.12.1. I should say ping. It's taking some time to learn the ARP. Let's jump ahead on router through 3 interface f80/1 IP address 10.1.23.3 255.0. No shut. Let's say just do a ping 10.1.23.2 to the router 2. Voila, looks good. Okay, so right, so let's start doing our BGP configurations now. So far what we have done is we have these IP addresses configured here, 12.1 and 12.1.23, and we have this up and working. Okay, so let's go ahead and configure this IP address on one of the loopback interface of router 1, and we will bring up the BGP between router 1 and router 2, also between router 2 and router 3. So let's go ahead and do the BGP configurations first on router 1 and router 2. Okay, let's confirm router BGP 100 neighbor 10.1.12.2 remote autonomous system is 100. Let's go ahead and do the same configurations. Router BGP 100 neighbor 10.1.12.1 remote autonomous system is 100, and we should see a BGP coming up shortly here. Let me bring the second neighbor 10.1.23.3, remote autonomous system is 100, and we will go ahead and configure router BGP 100, neighbor 10.1.23.2, remote autonomous system is 100. Let's wait for a minute for BGP to come up. Show IP BGP summary. It shows state is active. It's still in active state. Let's do a quick ping test to make sure that we have reachability. BGP is going to take 180 seconds. Okay, so we could see that the BGP is up here. BGP neighbor shows up. So let me quickly verify. Show IP BGP summary. Here you could see the we have neighborship with 10.1.23.2. The autonomous system is 200. Message is received and message is sent, and you could see that this is up since 12 seconds, and we have received 0 prefix, which means that if I execute show IP BGP, I don't have any prefixes learned here. Similarly, let's jump on to router 2 and verify that we have 2 neighbors. Show IP BGP summary. We have 2 neighbors. Okay, so what we have done is on this router I have performed an IBGP between router 1 and also on between the router 3. So I am on router 2 and you could see that I have 2 BGP neighbors. Okay, so I am on a router 2 here and I have BGP neighbor with 10.1.12.1, which is this IP address, and the next neighbor is with 10.1.23.3, which is this IP address. Okay, so far we are good with the configuration. So what we are going to do is we are going to add a loopback IP address with this IP address 200.0.0.1, and I'm going to advertise this route into the router 1. Okay, so this route should come to router 2, but this should not be advertised to router 3. Alright, so let's go ahead and configure a loopback interface. Loopback 200, I'll give IP address 200.0.0.1, 255.255.255.0, and let me advertise this route into BGP. So to advertise this route, I'm going to use the network command 200.0.0.0. Mask will be 255.255.255.0. So now I'm advertising this route into the BGP. Show IP, a quick verification from router 1 to see that we are advertising this. Show IP BGP neighbor 10.1.12.2 advertised routes. Okay, so we could see that this 200 network is being advertised from router 1. This is the best path. The star indicates that this is the valid path, and greater symbol tells that it is the best route. Okay, so this is being advertised from router 1. So let's quickly understand this. So this network we have created here 2001, and we are advertising this route into the BGP. So let's verify on the router 2 if we have learned this route. Show IP BGP summary. You could see that one route or one prefix is received from 10.1.12.1. Okay, so if you go ahead and check that, show IP BGP, you could see that it's a best route, it's a valid and best route 200.0.0.0. I am learning from 10.1.12.1. So far this looks good. Show IP route, show IP route. You could see that the route is learned from BGP here. The same route should be advertised to the router 3 as it is in its routing table However, it is not going to do that because of BGP Split Horizon Rule, which tells that the routes will not be received on router 3. Okay, so let's just quickly verify. Show IP BGP summary. You could see that we have received 0 routes. Show IP BGP. You don't see any route. Do show IP route. You don't see any route here. This is the BGP split horizon to avoid any routing loops. Okay, so far we are good with this. So we sent a route from here 200. It is learned on this, but this route is never getting advertised to the next router. Okay, so to fix this problem, we have two solutions. First thing is that we could configure this router 2 as a route reflector client. Route reflector client. There is one command you need to execute: neighbor 10.1.23.2 route reflector client, and also you need to execute neighbor 10.1.12.1 route reflector client, which means that this route learned here will be propagated to router 3. So let's verify that. Let me see if we could log the messages. Debug BGP updates, debug IP BGP updates, debug IP BGP events. Let's see if we could capture the route which is learned on router 3. Okay, so let's verify quickly what our configurations look like. Show running section BGP. Okay, so the configurations are pretty straightforward. Let me go ahead and configure route reflector client, router BGP 100, router BGP 100. The command is very simple. It's neighbor 10.1.23.3 route reflector client. That's it. Please note that when you configure a route reflector client in a production network, your BGP neighbor is gonna flap. So you could see that the BGP neighbor has terminated and it has come back up. So this will be a disruptive change. So if you are in a production, please make sure that you have all the downtime and things like that. Okay, so I am on I am on this router now, and we could see that debugging messages are logged in here, right? So let's see what's happening. Okay, here. Okay, so when we configure this route reflector client, okay, let me stop the messages. Okay, when we configure the route reflector client, uh, the BGP neighbor got reset. BGP 10.1.23.2 reset due to peer close the session. When we configured the route reflector client, the router 2 closed this TCP session of BGP, and it has come back again. As soon as it has come back again, you could see that we received an update from router 2. Okay, and then we could also notice that we have received this route 200.0.0.0/24 now, which earlier was not received. But there's one more problem in this network, that you could still see that this is not a valid path. It also tells that this is still not a valid path. 200.0.0.0 is still not a valid path. So let's quickly verify. Show IP BGP summary first to make sure that we are receiving that 200 network. So we have received this 200 network. If I execute show IP BGP, you could see that this network is learned 200.0.0.0, and you could also see that this is internal. I indicates that internal, it's a valid, but what we are missing is this greater symbol. This is still not a best route. Okay. Okay. So can you think of what would be the problem here is? Any idea? In my previous classes, we discussed about BGP synchronization, which means that when you have a BGP, okay, the rule of synchronization says that any BGP routes, IBGP routes, if you learn any routes from the third party, it will need to be, and when you're advertising it to the next router, it needs to it needs to learn through IGP. So you should have the interior gateway protocol. It could be your OSPF or EIGRP or any other routing. So what we are going to do here is that I'm going to use IGP configurations here. Okay, so we were discussing that the 200 network is learned, however, it is still not the best path, right? So what we are gonna do is that let's quickly verify show IP BGP 200.0.0.0. You could see that the next hop is 10.1.12.1, which is not accessible. So you should have a IGP running in the network and you should have reachability to 10.1.12.1. So what we will do is let's configure any IGP protocol for an instance. Let's configure router EIGRP or router OSPF1 and neighbor 10.0.0.0, or let's say let me advertise all the networks. Okay, sorry, it was my typo. Instead of neighbor, we should use network. No auto summary. Show running section OSPF. Let's do the same configuration on the other three routers quickly. Okay, now I should have the BGP route here. Instead of inaccessible, it should come as um, reachable. Let's see why are we still not having the neighborship. Why are we still not learning this route? Okay, the OSPF was still converging and I could see that it's loading and then it has converged to full state now. So I should see this route here, which means that we should have this route as accessible, and that's it. You could see that this is the best path now, one available route, and it's the best path and it is reachable. So this is the BGP split horizon rule. You could see that in before we configure the route reflector, the route was not learned from BGP, IBGP neighbor, and as soon as we configure this as a route reflector client, you could see that the route is learned. Okay, so what we will do is now let's remove the IBGP route reflector client configuration. The first solution which we applied, we will remove that. show running section BGP confirm router BGP 100, and I'm going to remove this command. You could see that as soon as you remove this, the BGP neighborship is gonna flap. And let me verify this again. You could see that show IP BGP neighbor, and the route is not learned in the BGP because of rule of BGP split horizon rule. Okay, so now the same scenario again. We are back to square one. The router 1 has advertised this route into iBGP. The router 2 has learned this, but router 2 is not sending this route to the third neighbor. So we had seen the first solution, that is BGP route reflector. Now we will see the second solution, that is BGP full mesh. Let's quickly verify. Show IP BGP 200.0.0.0 is learned here. Okay, so you could see that this route is here. Now BGP full mesh means you should have neighborship from each and every router. So the same topology I'm going to draw this way. Router 2, this is router 2, then you have router 1, and this is router 3. We have these iBGP neighbors this way, and now we need to have one more iBGP neighbor to make this as a full mesh. As soon as we establish this neighborship between router 1 and router 3, then this route will be propagated. Okay, so let's go ahead and do this. From router 1, so from router 1 I should have a reachability to router 3. So the router 3's IP address is 10.123.3, and 10.1.12.1. Okay, so alright, let's go ahead and do this. Router BGP 100, neighbor 10.1.23.3, and remote autonomous system is 100. Router 3, let me just jump onto the router 3. Router BGP 100, neighbor 10.1.12.1, remote autonomous system 100. Okay, and now you can verify that the BGP neighbor has come up, 10.1.12.1. Now on this router, show IP BGP 200.0.0.0, and I should have this route here. Okay, so far we have seen the two possible solutions for the BGP split horizon rule. Okay, the first solution we saw is a route reflector client, and the second one is BGP full mesh. Thanks for watching this video, and I hope this has been informative. If you like this video, click on like button and subscribe my channel to get the more videos regarding BGP and all other technologies. Thanks a lot. Have a good day.